Hey there, Taylor here to give you a demo of the Blocky Jenkins file for building Ethereum smart contracts called the loading ramp. The loading ramp is a CI/CD pipeline for developing, testing, and delivering Ethereum smart contracts in a usable, super simple Jenkins pipeline. So what we're going to do is say we are working on this particular smart contract. It's a pretty simple smart contract here, but we've gone ahead and written it out, and we've got some tests written out so we know what it's doing through here. And then we also have a package, a file put together, folder put together to contain all this information. So if we go ahead and look, we have the same information here on demo smart contract. This is put up to Bitbucket. And this is the smart contract that we're going to be testing, deploying, and working with on the Ethereum network in our CI/CD pipeline. So there's an order to this folder that's been created and put up on Bitbucket. I'll go into that here in a minute. But to start, I'm going to go ahead and set up this pipeline and run it. And once it's running, we can talk about exactly what's going on underneath the hood. So here we're going to have the loading ramp name and the pipeline. So we'll get the project started. We're just going to put some lorem ipsum in there, and we're going to keep this just pretty vanilla for right now, and that's just for brevity in this tutorial. But as you go on, you can have any sort of build triggers that you want to for this pipeline. It's going to work with those as well. So we're going to be pulling this pipeline from source management, and that is this ramp Bitbucket file here, a folder here, repo here, and so we're going to clone the URL for this right here. And we are going to select get and put the URL right in here. So we've got our ramp Jenkins file set up right here. It does pull from does not require any credentials. It does pull from the master, and our script path is Jenkins file. So that's all pretty good to go right there. As we click save, we have one more thing to do. So we're going to go back up to our main directory here in Jenkins and go to Manage Jenkins and Configure System. Here is where we're going to tell Jenkins where to look for our repository. So we're also going to copy the URL for the smart contract repository that we have, and we're going to go down here, and you can see I've enabled environment variables, and I've added one that is called contract repo. The value for contract repo is going to be the repo URL for our Ethereum smart contract. We go down here and we click save, and we are good to go. Now that we have our loading ramp Jenkins file installed on Jenkins, we are going to go ahead and run this Jenkins file pipeline and talk about what's happening underneath the hood as it goes along. First thing we'll do is navigate into the Jenkins file and click Build Now. We're going to see a series of stages appear down here that are going to indicate the process that we're going through. First things first, we check out our source management, which is looking at the ramp file here on Bitbucket and pulling in this Jenkins file. Next, we move into cloning, which is going to take a look at our demo smart contract. This is pulling in from that environment variable we set earlier. One thing that I want to draw your attention to is the configuration of this demo smart contract repo. We have our inbox.sols, which we're working on, our test files, which our tests are all using Jest, and are basically part of this package. Jest is a part of this package.json file. What is also included in this package.json is the loading ramp library. This is a custom-built library by Blocky that allows you to is basically the backbone for this loading ramp pipeline. It includes modules that make deploying to the Ethereum test networks and the main chain possible. It makes managing the addresses that come out of that so that you don't have to worry about knowing where your smart contracts are deployed in this process. Extremely easy. It kind of abstracts that all the way for you. And it includes some extremely powerful tooling around building your tests so that you don't have to worry about how to reach out to your smart contracts and run certain functions that you want to test in your testing suite, you can just go ahead and call this package in your testing suite, and all of that is handled for you. It's extremely easy, it's extremely streamlined, and it helps a ton with not only running this as the backbone of this pipeline, but making the testing process extremely simple. So we have that package is included in package.json. One more thing I want to talk about is this configure.json file. This is described in the documentation for the ramp, but it's really important in order to facilitate the deployments of your smart contracts in this pipeline. Essentially, it is the central hub for all the important information regarding deploying to the Ethereum networks. There is more documentation on it. As long as you fill out this information, it's going to be good to go. But it is something that is needed to be in the main directory of your smart contract in order to work. So moving on from the cloning stage, we're going to go to environment prep. Environment prep is basically running an npm install so that everything in our deployment pipeline is, all the node dependencies are installed and ready to run. Once we move into this deploy step, it's going to deploy two versions of the smart contract inbox.sol that we have created. The first version is going to go onto our test RPC. That smart contract is run locally, and it's a really good way to get instant feedback on our smart contract. If there is, for some reason, something going on where the smart contract doesn't compile, then that's going to be the first thing that throws an error, and we're going to know right away that we have a problem with our smart contract. This same smart contract inbox.sol is also deployed to a Ethereum testnet of our choice. That choice is set up in the configure.json file. When that contract is deployed, it is a more robust Ethereum network, and so we can get some better feedback on exactly how our Ethereum smart contract is working in the wild. Once both of those smart contracts are deployed to their respective test networks and we get the okay that happened properly, then we move on to the test phase. Test phase is going to take a look at our testing files and run those against the smart contracts we have deployed on the two networks. This is great. This allows us to make sure that everything is happening properly. And again, the tooling that we built around the loading ramp library, it makes this so simple to work with in your actual testing. Finally, we move on to, if those tests pass, we move on to approve prod deploy. So I'm going to go ahead and proceed here. I have this retooled so that instead of deploying onto the live Ethereum blockchain, it is redeploying onto the testnet that we selected. This is because it costs money to deploy onto the live blockchain, and we're just going to avoid that to make it easier on here. Otherwise, this would be working exactly the same. If we clicked approve prod deploy, it would be going onto the live Ethereum blockchain and would have an actual contract address that is saved to our computer that we can access whenever we need to. Here we go. So we can see that it has deployed to prod. And just so you guys can see that this is actually working as intended, we're going to go to Etherscan here. We are deploying on the Ropsten test network, and I'm going to refresh this, and we can see here a couple different things. We have a smart contract created 4 minutes ago. That is the smart contract that was deployed onto the Ethereum testnet, Ropsten testnet, in this deploy section. We also have some calls out to that smart contract here, which is 4 minutes ago. That happened in our test stage here. And finally, we have another contract creation. This was in deploy to prod. Again, this would be on the live Ethereum network if it was configured to do so. But again, just to save some money and make it easy, we have done this back to the Ropsten network. But essentially, we can see our two contract creations and our test suite did get run against the smart contract, showing you that it happened in the way that we expected. Finally, yeah, well, that's about it. That should cover everything that we have in this demonstration, and hopefully that gives you a really good understanding of how the loading ramp from Blocky works and how easy it is to test, deploy, and deploy to prod all of your Ethereum smart contracts in a very simple CI/CD pipeline.